Okay, let's talk about the rational root theorem. And this is an extremely important theorem in mathematics and specifically algebra. And it has to do with solving polynomial equations. So if we take a look at this particular function, this is a polynomial function. It's a third degree polynomial function. So if the objective here is to find the solutions, find the zeros, roots, those are all uh, different terms that basically mean the same thing. It means take this equation, this function, this polynomial function, set it equal to 0 and solve for x, right? So that's what we're trying to do here. And the rational root theorem is going to assist us in this objective, okay? But before you kind of study the rational roots, you need to already have a pretty strong background in solving polynomial equations. First of all, you need to know a few things before we kind of get into this video. One, what is a polynomial? Another thing would be useful is what is a rational root? Okay, what is a rational root? And let's just quickly cover some basic concepts that hopefully you already understand. If you don't quite know what I'm talking about, please continue to watch the video. I think you're definitely going to benefit from it. But it's an indicator that you need to do some review. Okay. All right. So first things first. So let's think about an equation like this: 2x plus 1 equals 9. How many solutions is to this linear equation? This happens to be a polynomial equation to the first power. There's just one solution. Okay, how about this? X squared equals 16. This is a second degree polynomial equation. We call these guys what? Quadratic equations. There are two solutions. Okay, so for example, here, if I said take this part of this equation, this polynomial equation, let's forget this for a second, and set it equal to 0, how can I solve this quadratic equation? Well, a quadratic equation is a degree 2 polynomial, okay? So I'm thinking to myself, well, how many solutions is there? There's two solutions. There's always two solutions to a quadratic equation. Well, how can I find them? Well, I'd like to be able to, let's say, maybe factor this. That'd be great. But if I can't factor a quadratic equation or a degree 2 polynomial, I can always break out my trusty friend, the quadratic formula, and that can handle any situation, right? So I can just take my quadratic formula, apply it to whatever degree 2 polynomial equation I have, and I will get my solutions. So when we're talking about polynomials, solving degree 1 and degree 2 polynomials, we can, there's direct paths. We can always get the answer. But things get more interesting when we have a third degree polynomial or higher. So like this particular problem, there is no quadratic formula for degree 3 polynomial. We can't just plug this stuff into some formula and get the answer. So we need additional tool. We need new tools. Okay, so we need to already know how to solve quadratic equations on obviously linear equations. We need to know how to do this, but above and beyond that, we're going to need some more advanced, methods to be able to solve this polynomial equation, and that is indeed the rational root theorem is one of those methods that we need to understand. Okay, so again, you should have a good, strong background in solving quadratic equations and understanding basically the fundamental theorem of algebra, which states that if I have a polynomial equation, the degree of that equation, okay, so this is a third degree polynomial, all right, means that there is three solutions. There are three solutions to this polynomial. Now, what type of solutions? Well, we can have real numbers or imaginary or complex number solutions. We just don't know until we get into problem solving, okay? Now, part of the real number system, okay, one type of number is rational roots. So rational roots are numbers that you'll think of them as integer values, let's say like -3, 2, 1, okay? But technically rational roots are numbers that we can express as fractions of integers. So like -1/2, okay? Or 2/3 or 7/10, okay? These are numbers that we can, any fractions that where the numerator and denominator are integer values, whether they be positive or negative, all these numbers together are rational roots, okay? So obviously the rational root theorem has something to do with rational numbers. Okay, so with all that kind of being said, I'm going to get into the direct application of the rational root theorem here in a second. But it's important that you have this foundational, background information, because if you didn't understand what I just got done talking about, then this might be a little bit more complicated than you might think. Okay, it's not overly complicated. You could still understand this, but in terms of you mastering this, you got to master the other stuff that we just talked about before you can master the rational root theorem. Okay, so I want to get all that in a second, but let me first quickly introduce myself. My name is John. I'm the founder of TabletClass Math. I'm also a middle and high school math teacher, and over the years, I've constructed what I believe is one of the best online video-based math help programs there is. So whether you need to take a full, comprehensive, complete math course, I offer that, or you need assistance with a course that you're taking right now, I can help you out. All right, so you can find a link to my math help program in the description of this video. Those would include full, comprehensive, very detailed lessons on all the topics. You're basically within middle and high school mathematics. And I teach you how to solve the most common math problems that you're going to find at those levels of mathematics. I literally solve thousands of problems, all video based. So really great program that's taken me years to build, but I'll let you be the judge of it. If you're interested, you can find it in the link in the description. Now, as a math teacher of teaching for decades, there's one thing that I need to stress to you is math notes, okay? It's just as a general golden rule of math that I've seen is those students who take great math notes typically have great math grades, and the reverse is true. Those students with no notes, sloppy math notes, maybe their dog ate their homework and their math notes, whatever the case is, take a look at your notes, okay? Make an honest assessment. All of us have room for improvement. Very, very few people take perfect math notes, but yet, if you're really struggling in this area, that's your first starting point to really improve in mathematics. But in the meantime, you need something to study from, so I actually offer very detailed, comprehensive math notes. Those would include pre-algebra, Algebra 1, Geometry, Algebra 2, and Trigonometry. For the rational root theorem, you'll want to check out my Algebra 2 trig notes. Okay, let's get into the rational root theorem. Again, I just laid out as an introduction to this video what we're talking about. The objective here is to solve this third degree polynomial equation. So, by the way, the rational root theorem could apply to quadratic equations as well, but we don't really need to apply it because we already have the quadratic formula. It's not really necessary, but the objective is how do we solve third degree or larger polynomial equations? We need new advanced tools. Obviously, the rational root theorem being one of them. Okay. So here is a quick overview of what it is. And basically, rational root theorem states that any rational roots the polynomial may have, okay, there's no guarantee that the polynomial is going to have rational roots. Okay, we already described what rational roots are. They're like numbers like 2, -3, 1/2, -2/5, whatever the case is. But here's the thing, right? If any rational roots the polynomial may have will be in the form of the factors of p over the factors of q. And what is p and q? So up here, okay, q is the leading coefficient. So notice that my polynomial is written in standard form. When you write a polynomial from the highest power to the lowest power, your leading coefficient here is q, okay? And your last term, your constant term here of the polynomial, the number, okay, if you will, is p. Okay, so we're going to look at the factors of p and the factors of q, the leading coefficient and the last number in the polynomial when it's written in standard form. Okay, so we're going to go ahead and do that now. And then we'll see how we actually use this information. Okay, so here's q and here's p. Okay, so what's the factors of p? Well, p is 16. Okay. So I'm gonna talk about all this here in a second, and then we have the factors of q. So q is 2. All right. Okay, so let's talk about 16. What are the factors of 16? Now these are the factors of 16, but let me explain this for a second. The way I'm doing this here is the way you want to do this in practical application with the rational root theorem. So 16, let's say for example, is equal to 1 times 16. Positive 1 times positive 16 is 16, and negative 1 times negative 16 is also positive 16. So 1 and negative 1 are factors of 16. So I'm going to write that as plus or minus 1. There's no need to write 1 and negative 1. Okay, we can just write it as plus or minus 1. So the way you want to list the factors of your numbers, let's take 16 here, for example, is you're going to always start with 1, and you're always going to have a plus or minus. You don't have to think about this. Always going to be a plus or minus. So let's just think about it. All right, 1 is always going to be a factor of any number. And of course, 16 is a factor of itself. So that's going to be our last number. We're going to start small and we're going to work our way up to 16. Okay, start with the smallest numbers and work your way up. So just think to yourself, okay, what's the next smallest number that's a factor of 16? Oh yeah, 2 times 8 is 16. So that's going to be positive negative 2. Then you start thinking 3, no, 4, yep. 4 times 4 is 16, so that's positive negative 4. 8, okay, it's the next one. 8 times 2 is 16, positive negative 8, and then we have positive negative 16. Always positive and negative. Always write it just the way I'm doing it like this. Okay, so factors of 2, remember, 1 is always your first factor, positive negative 1, and then of course 2 is our last factor of 2, positive negative 2. Now, once you have all your factors listed, okay, the next step is the following, okay? And this is where students often get confused with this. All right, we're going to take one of the denominators. We have to list all the combination of numbers we can make out of these various factors combinations. So this is the way you do it in practicality. We're going to take the first denominator, it's going to be 1, okay? And we're going to divide it into all of our possible numerators, okay? So now, for when you're doing this, just forget the positive and negative mentally in your head. Let's just look at the number, okay? So in other words, 1 divided by 1, I don't need to go positive negative 1 divided by positive negative 1. Just mentally, just go 1 divided by 1 is what? That's 1, okay? 2 divided by 1 is 2. Okay, now when you write your list here, you definitely need to put the positive and negative down there, but we're just making these combinations. 4 divided by 1, of course, is 4. 8 divided by 1 is 8. 16 divided by 1 is 16. Okay, so you're going to list all your numbers down there. Then what we're going to do is we're going to now switch to the other factor, the next factor in the denominator, okay? So now there might be more. This is like positive negative 1, positive negative 2, but maybe there's like positive negative 3, okay? In some problem that I might be doing. So we're just going to go to the next factor in the denominator and start looking at the different combinations, okay? And add it to our list. So we have positive negative 1, or sorry, 1 divided by 2 is what? 1/2. So that's got to be in our list here. Now, 2 divided by 2 is what? That's just 1. That's already in my list. 4 divided by 2 is 2. That's in my list. 8 divided by 2 is 4. That's in my list. And then 16 divided by 2 is 8. That's in my list. So here, okay, I listed out all the different possible combinations of these factors, right? This is very important. That's where students get confused. But what does this mean? Well, if this polynomial that we're looking at, okay, has any rational roots, it's one of these guys, okay? It's within this set. So these are all the possible rational roots. There's no guarantee, okay? There's no absolute certainty that this polynomial function, okay, has rational roots. We just don't know. I do know that it has 3 roots, okay? They could be real or imaginary, okay? And there's other theorems and things that can help us out with this, but the rational root theorem is just one theorem, a part of other things that you need to, rules and techniques that you need to know, but very, very important. So we're like, okay. So if this polynomial equation has rational roots, it's going to be found with these guys. All right, so what do we do? Well, is that all of it? No, we want to now do what? Well, let's go test these guys. Let's see if we actually have any rational roots. So let's start testing for zeros. Zero is another word for roots or solutions, okay? So basically, answers, right? We're looking for the solutions to this equation. So here is our list that we just created with all our possible rational roots. So how do we start testing for zeros? Okay, it's pretty straightforward, right? There's 2 ways you can do this, and I'm going to show you the more common way here in a second. But if we have a solution, what we're really looking for, let's take here we have positive negative 1. So this means obviously 1 and negative 1. Let's test for 1. Let's start with the easiest number first. So if I plug in 1 into my function, if I evaluate this function for 1, all right, let's say, let me go over here. If I plug in and I'm looking for f of 1 and it turns out that that is 0, okay, if f of 1 equals to 0, then 1 is in fact a solution to this polynomial. Then I need to find, remember, I need to find 3, 1, 2, 3 solutions. So hopefully they're going to be a part of this list. If they're not, then we got to do other things, right? So the way we start testing is we can plug in these values. So like for example, let's plug in 1. And when I plug in 1 into my function here, you can see when I evaluate this 1 cubed, that's going to be 1 times 2. So you can see 1 squared is 1. 32 times 1 is 32. Now you just look here. There's no way all this right here is going to add up to 0. Okay, meaning that 1 is not a solution. So, well, I'm not going to be sad about it. I got a lot of other good numbers here to test, right? So then I would move on and test negative 1. And then I would, if that didn't work, okay. Now, if it did work, now that's a whole nother discussion, okay. So I'm really focusing in on the rational root theorem. This is part of the broader topic of solving higher order polynomial equations. But let's just kind of stick to the application of the rational root theorem. Okay, so I can just keep testing these numbers. I could test 2, negative 2, 4. I'm just looking for rational roots. Now, you can do it this way, but that's not the way your teacher is likely going to want you to approach it. Okay, so we know 1 is not positive 1 is not an answer. So we would go through this list. Now you can see here I'm highlighting values, rational numbers that are in fact are solutions to this polynomial equation. Okay, now let's go ahead and take a look at what I'm doing here. This is called synthetic division. You need to be familiar with this, okay? Hopefully you know how to use synthetic division, but this is how it works, okay? So you can see my coefficients here, 2, negative 1 in front of x squared, negative 32, and then I have 16. So using these coefficients here, okay, I'm going to plug them down here like so, okay? If you don't understand synthetic divisions, check out my video on the remainder theorem. I'm going to make a dedicated video on polynomial division and synthetic division. So that may already be like in my Algebra 2 playlist, but this is what you need to kind of structure, okay? So let's go ahead and test positive 4, okay? How does this work? Well, again, I'm assuming that you may know a little bit about synthetic division. It's really, really cool technique, and this is the easier way to evaluate or to test for zeros. Okay, so you see this little 2 right here? This 2? First step is, once we get this all written correctly, and we do this little L thing just like this, you make it just like this, we're going to drop that number right there. Okay, boop. Now we're going to go 4 times 2 is what? That's 8. Okay, so negative 1. Now we're going to add down. Plus 8 is 7. Okay. Now we're going to go 4 times 7 is what? 28. Then we're going to add down. Negative 32 plus 28 is negative 4. Okay. So make sure you understand what I'm doing. I'm adding down. Now I'm just going to continue the pattern. 4 times negative 4 is what? Negative 16. And when I add down here, this is my remainder. It is 0, okay? Meaning that if I was to plug this into this function, f of 4, into all of this stuff, I would get 0, okay? So that's an indicator, that is validation, that 4 is, in fact, a solution to this polynomial equation, okay? And if you keep testing, you'll see that negative 4 is 1 as well. And then either positive or negative 1/2, I can't remember which one is, but we can go ahead and actually let's test for positive 1/2 real quick, just to kind of reinforce how this stuff works, okay? I think it's positive 1/2. I already did this problem in advance, but let's put 1/2 right here. let's test for 1/2, okay? So again, you're going to take this first number, drop down there. I don't know if that's 0. Okay, so 2 times 1/2, okay, is 1. -1 plus 1, 0. 1/2 times 0, 0. -32 plus 0 is -32. 1/2 times -32, -16. Look how awesome this is. 16 plus -16 is 0. So here we have 1/2, and we have our positive -4. So 1, 2, 3 solutions to my third degree polynomial. I am all done. They happen to be all rational roots, but there's no guarantees, okay? So again, a rational root theorem says, listen, if this thing does have rational roots, it's going to be amongst this whole list that you create with these factors of p's and q's. Very, very, very important theorem indeed. And of course, there's a lot involved here. And I can keep going on and on. That's why you really need to, look at additional YouTube videos that I've made. But if you really want to master this stuff, you got to maybe jump into my Algebra 2 course. Okay, I really get into this because other techniques we want to consider. We want to be looking at graphs and the De Moivre's theorem, not De Moivre's theorem, Descartes' rule of signs. There's other things here that can help us solve, because let's suppose that we didn't have any rational roots. Let's say we didn't find, we tested all these guys and we didn't have any rational roots. We would be very sad because we were like, what do we do now? Well, then now we got to have to use the, more techniques, okay, to help us solve and find those 3 solutions. But you always want to start with the rational root theorem, okay? Extremely important in mathematics. So if this video helped you out, if you're studying the rational root theorem and now maybe this cleared things up, please consider smashing that like button. I would appreciate that. If you're new to my YouTube channel, hopefully you'll become a subscriber. I already have, again, a lot of videos related to polynomials. I have a lot of videos on a lot of subjects organized in various playlists in my channel. So hopefully you can check that out. Those are there for you. But my best resources are going to be found by following the links in the description of this video. Again, if you really want to learn this, I would suggest my Algebra 2 course. At the time of this video, I am going to be launching a pre-calculus course, which is going to really get into some heavy-duty mathematics. So that I'll let you, if you're following my channel, I'll let you know. I'll make a special announcement on that. But you can find all this in my Algebra 2 course or college algebra, whatever the course you're in. I teach that in that course. Okay, so with that being said, I definitely wish you all the best in all your mathematics adventures. Thank you for your time, and have a great day.